In this video, I'm going to go through a new version of CAIRN, which is a little bit more streamlined than the original one. This doesn't have any documentations at the moment, so I'm just going through a few steps that you can use to get started, and at some stage the full documentation will be there. So the first thing I'm going to do, I'm going to go through the standard LSDTopoTools installation, or I'm going to start in the standard LSDTopoTools way. If you don't know how to do that, in the full documentation website, there's the installation instructions. But basically, I'm using, in this case, a Docker container for it. I'm going to use the PCL Docker. So that puts me into LSDTopoTools. And I want to make sure everything's set up. So if you install, you'll have it all set up. But so I'll go into LSDTopoTools 2. I'll go into the source directory, and I just want to build all of the source files. I've already done this, so this should take really no time at all. And then I want to make sure my terminal is working. So, so this just lets my computer see where LSDTopoTools is, and the program I want is this one, LSDTopoTools. Okay, in the updated version of this, you can just navigate to your data directory. So I'm going to go into the data directory, and I've put the data into example topo data sets, and it's in a directory called CRN data. This you can find on the TopoTools website. So if you go into example topo data sets, this is all in a repository. So in CRN data, you'll have these files. So they're sitting on my directory as well. And these files are also going to be on my Docker, in my Docker directory. So to do this, in the old CAIRN, you had these three files, the crndata.csv, so here, the crnresters.csv, and the crn parameters. If you want to do it with the new one, you also need this driver file. So that's going to run everything. Now let's look at the driver file. So just shrink this down. So here's the driver file. So to run this analysis, you just need to comment and uncomment lines from this driver file. So basically you have step 1, step 2, and it goes all the way down to step, that should be step 4. Yeah, so we're just going to comment and uncomment these things. So step 1 is to just check the basins. So when you do this on your own data set, you would change the read name of your DEM. So that's the prefix of the DEM. And then you also have the Cosmogenic parameter prefixes. So in this case, the prefixes in both of those things are burn, but theoretically you could have different prefixes for these Cosmogenic parameter files. Okay, so I've just uncommented that. I need to save that, and then I just run this LSDTopoTools, and then I call this driver. Okay, so that's going to churn away for a bit. What it does is it basically reads the data file, the CRN data file. It writes a hillshade so you can look at it, and then it also gets the basins out of this, out of the combination of the DEM and the points where you have your data. And I did a version earlier than this, so you can basically see where the basins are by using that check basins. So you can load the CRN data, you can load the basins, and you can check that your basins are in the right spot. Okay, next bit. So step 2, I'm just going to uncomment this. Now I want to spawn all my basins because that just speeds up the analysis. So I just go right back in. I've changed this. I've saved it. So now I just need to run this again. Oh, actually, I know that will not work because to spawn the basins, you first need to make a directory that that is the same name as your data prefix. So if you don't do that, the program is going to look for this directory to put in files. So you need to make that directory. So let's see if it's there. So I have a new directory of this, and now I'm going to run that again. So I'm going to run this and spawn them. So now it's spawning the basins, and that should take a little while, not too long. So there we go. That's all the basins spawned. So if we go into that directory, you can see all these new spawned basins. Okay, next step. We get rid of these. Okay. Now, when it spawns the basins, it gives a new file name to some parameters. So if we look at this again, you'll notice that these new parameter files, it just made these new parameter files, these 3 ones here, sandburn spawn, spawn, spawn. So the prefix of the parameter files has spawned in it. So when you update your parameter file, you need to change this to have this spawned thing in here. Now the next thing I'm going to do is make shielding rasters, but actually what this does is you can calculate the shielding. So if I wanted to calculate the shielding, I would put calculate shielding true here. But the default is, instead of calculating the shielding, to just set all the shielding to no topographic shielding. And that's based on a paper that Roman DiBiase had in eSurf saying that we shouldn't include shielding. This has the side benefit of being much, much faster to run. So basically all this is going to do is just going to make rasters that have shielding factors of 1, which is effectively no shielding. So I'm going to run this now. So that's the next step. So I just run this again, just like last time. So that just ran a bunch of shielding. And now if I go into the shielding data set, or the spawn data set, you'll see that every spawned basin has an additional shielding raster out alongside it. So this will get read by the updated code. So so it's generated new parameter files, and if I look at these, sorry about all the beeping. So if I look at what this says, it has, you'll see in the CSV file, these shielding rasters associated with them. Okay, so we're ready for the last step. So comment this stuff out and put the last bit. So you'll see I updated the parameter prefix. So I added the shielding bit. You have to say use spawned basins, so that knows to go into the spawned basin directory and find all these new basins, and then it's just calculate erosion rates. So save that and go in here and run this again, and that'll churn through all the basins. Okay, that's all finished. Now I can see what's here, and you can see that there's the results file. I'll just look at this in here. Here's the results file. So we can look at that, and it just looks like this, which is the normal output of CAIRN. So that's how you get from the raw data all the way up to the actual erosion rates from your samples. Okay, thanks very much. Hopefully that works for you, and hopefully you can adapt this to your own data set.